In this video, we'll be talking about standard 14, parallel lines and transversal proofs. So we have to write a paragraph or two-column proof to prove the angles are congruent, or to prove that lines are parallel, or to prove angle measures. Here's our first example. First of all, I write my givens first. So I know that line R is parallel to line S. I'm going to go ahead and mark that in my picture. R and S are parallel. Okay, I'm trying to prove that angle 1 and angle 8 are congruent to each other. So you first use these parallel lines to find something else out about angle 1 or angle 8. I see that angle 1 and angle 6, those are corresponding angles. Okay, corresponding angles we know are parallel to each other. Now we can't say that lines are parallel to each other. We can't say that corresponding angles are congruent to each other unless we use the picture and the parallel lines. So I see that R and S are parallel to each other. Well, because of that, I know angle 1 and angle 6 are corresponding angles that are congruent to each other. So I can say angle 1 is congruent to angle 6 in my second step. Next thing I see, angle 6 and angle 8, those are vertical angles. I better mark my congruent stuff here. Angle 1 and angle 6 are congruent. And then I see angle 6 and angle 8 are congruent to each other because they're vertical angles. And I get that from the picture. Well, if angle 1 equals angle 6 and angle 6 equals angle 8, then wouldn't that imply that angle 1 equals angle 8? And I see that we're leading towards that in this picture. We probably just don't have a property name for it. So that's where transitive property comes in. It says if A equals B and A equals C, then B has to equal C. So if you have something that equals two different things, well, those two different things also have to equal each other. So our last statement will say then, angle 1 equals angle 8 by transitive property. So I combine 2 and 3 to get angle 1 equals angle 8. My givens are already marked in my picture. Line L and M are parallel to each other, and lines A and B are parallel to each other. So I went ahead and wrote those in my givens already. Next, I want to use what I'm trying to prove. Angle 1 is congruent to angle 5, so I want to use angle 1 first. The first thing I see about angle 1 is that it's vertical with angle 2. So if they're vertical to each other, that means they're congruent to each other and their measures are equal to each other. So my statement number 3 says angle 1 and angle 2 equal each other. The picture proves that to me. My next statement says that 4 and 5, I'm trying to get to 5. So 4 and 5, those are also vertical angles, so they're equal to each other. The next thing I see after that is that 2 and 3, those are consecutive or same side interior angles. They're between lines L and M, so interior, and they're on the same side of this transversal A. So angle 2 plus angle 3 equals 180 because they're consecutive interior angles. And that is by the picture and by statement number 1, because those are our parallel lines. If we didn't have our parallel lines, we wouldn't know that these consecutive interior angles are actually supplementary. The next thing that I see is that angles 3 and 4, those are same side interior or consecutive interior. They're both in between parallel lines A and B, and they're both on the left side of this transversal M. That makes them consecutive interior angles. So that means angle 3 plus angle 4 equals 180 degrees because consecutive interior angles are supplementary. I see it in the picture, and I know that they're supplementary because of the parallel lines A and B. So we already stated that A and B are parallel lines, so that's enough information to say my consecutive interior angles are also supplementary. So here I'm seeing that 2 plus 3 equals 180, 3 plus 4 equals 180. Well, this implies that 2 and 4 have some sort of special relationship. So the way I could think about this is, if I subtract angle 3 from each side, then I would have angle 2 equals 180 minus angle 3. And if I did the same thing here, if I subtract angle 3 from each side from step 6, that would also imply that angle 4 equals 180 minus angle 3. Well, if that's the case, then angle 2 and angle 4 have to be the same as each other. So my step number 7, statement 7, says angle 2 equals angle 4, which I can see right here. That's just a substitution between 5 and 6. Well, if angle 2 equals angle 4, and I already know angle 1 equals 2 and 4 equals 5, well, that would mean that angle 1 has to equal angle 5. So that's by substitution. I combined 3, 4, and 7 to get 1 equals 5. So for statement number 7, I took that angle 1, plugged it in right here. Statement number 4, I took that angle 5, plugged it in right here to get angle 1 equals angle 5. My last example. Line G is parallel to line H, and I know angle 1 and angle 2 are congruent to each other. Go ahead and mark that. Okay, well, let's use that line G and line H are parallel to each other. If that's the case, then angle 1 and angle 3 have to be congruent to each other because they're corresponding angles. They're in the same spot. So angle 1 is congruent to angle 3 because of the corresponding angles between parallel lines. So I use that parallel line piece to say that they're congruent to each other. And the picture showed me that those are the spots where the parallel line, or where the corresponding angles actually are. So angle 1 is already marked this way, so I'm going to mark angle 3 the exact same way. Well, what does this imply? Angle 3 and angle 2 are also congruent to each other. Again, that's just the transitive property. I'm saying that if angle 1 equals angle 2 and angle 1 equals angle 3, then angle 2 has to equal angle 3 also. So that should be transitive property instead. Okay, well, if 2 equals 3, those look like alternate exterior angles to me. But if alternate exterior angles are actually congruent to each other, that means that those lines, P and R, are parallel lines. So one of the things we know is that if we have alternate exterior angles that are congruent to each other, then our lines are also parallel. And that's something we know if we had corresponding angles that are congruent, that would mean we have parallel lines. If we have alternate interior angles that are congruent, that means we would have parallel lines. Same side interior or same side exterior angles that are supplementary, that means we have parallel lines somewhere. So my last statement then says line P and line R are parallel to each other because if we have alternate exterior angles that are congruent to each other, that means our lines are parallel to each other. So I now know that lines P and R are parallel. And that's our last example.